Let us begin with problem set lambda. The first question is if m equals minus 1 raised to 1001 and n equals minus 1 raised to 1003, what is the value of m multiplied by n? You can pause the video, try it out by yourself, and then wait for the solution. So we can see that minus 1 to the power of 1001 would equal minus 1. Why? Because 1001 is odd. Similarly, 1003 is also odd. So even minus 1 to the power of 1003 will be minus 1. Because minus 1 to the power of say n, and if n is odd, minus 1 to the power of n would become minus 1, and if n is even, it would be 1. Because if I multiply minus 1 say twice, the product is 1, and if I say multiply it thrice, the product is minus 1. So if I multiply minus 1 an odd number of times, the result is always minus 1. So even in the case of minus 1 to the power of 1001 and 1003, the result would be minus 1. So now this is m and this is n. So m multiplied by n would be minus 1 multiplied by minus 1, and hence the answer is 1. So B is the right option. The LCM of two numbers is 36 and the product is 144. We need to find the HCF of these numbers. The options are given. So first of all, you should keep in mind the formula that LCM multiplied by HCF is nothing but the product of the given two numbers. So whenever we have two numbers, their LCM multiplied by their HCF be the product of those two numbers. So in our case, we have the LCM of those two numbers is 36 multiplied by HCF is what we need to find out, and the product of two numbers is given as 144. So my HCF would be 144 upon 36, which is 4. So the correct answer in this case is option A, 4. All of you need to remember this formula, that LCM multiplied by HCF is nothing but the product of the two numbers. So try to remember this formula. Next, we have a very simple problem. So we need to find the value of square root of 225 added to the cube root of 64. So first of all, what is square root of 225? This is nothing but 15, because 15 squared, that is 15 multiplied by 15 would be 225. So the square root of 225 is 15. Similarly, cube root of 64 is 4, because 4 cube is 64. Okay. Now if I add these two, 15 plus 4 would be 19. So the right answer is option A, 19. Next, we have to find the HCF of 17 and 19. So notice that both 17 and 19 are prime numbers. So the highest common factor of both the numbers would be 1. Because if you remember, if A and B are both prime numbers, they are relatively prime. They are also called coprime. That means their HCF would always be 1. So in this case, the correct option is A, 1. Next question. What is a multiplicative identity in the set of integers? So as we have seen in the case of whole numbers, the multiplicative identity even for the set of integers is 1. Why? Because whenever I multiply any integer, say I multiply an integer a with 1, it remains unchanged. So the correct answer in this case is option B, 1. What is the periodicity of 982.164164 and so on? So in this particular number, the repeating block is 164, that is 164 164. So 164 is my repeating block, and the length of this block is 3, because there are 3 digits in this block. So 3 would be the periodicity of this particular decimal number. So the correct answer is option C, 3. Now what is the period of the decimal 2.373737, so on? So the repeating part in this decimal number is 37. Now the length of this block is 2. So 2 is the periodicity. The block itself is 37. So the block itself is called the period. So in this problem we are asked what is a period. So the correct answer is C, that is 37. What do you call two fractions whose product is 1? So if you remember, if there are two fractions, say a by b and b by a, the product would be 1, and in this case they are known as multiplicative inverses, or they are also called reciprocals. So multiplicative inverses is there, reciprocals is there. So in this case there is option D, that is both B and C is the correct answer. Say we have 3 by 4 and 4 by 3, product is 1. So 3 by 4 and 4 by 3 are known as multiplicative inverses of each other or reciprocals of each other. Which of the following sets is not closed under subtraction? So if it is natural numbers or integers or rational numbers or real numbers. So first of all, you need to keep these notations in mind. So natural numbers is represented, the set of natural numbers is represented by n, set of integers is represented by z, set of rational numbers is represented by q, and set of rational numbers is represented by r. And similarly, set of whole numbers is represented by w. Now the question is, of these 4 sets, which of them is not closed under subtraction? So when I say that a set is supposed to be closed under subtraction, I mean that if I have, say, 2 elements in that set, a and b, and if I apply the operation, that is I subtract b from a, that is a minus b, this should also be present in the set that a and b belongs to. Okay, so in that case, I say that that particular set of numbers is closed under subtraction. For example, integers are closed under subtraction. Say, because if a and b are integers and I do this operation a minus b, I know this a minus b, say, which is results in c. I know that even c is an integer. So integer set is closed under subtraction. Now the question is, which of the sets is not closed under subtraction? And in this case, the correct answer is natural numbers. Because say I have two natural numbers, say 3 and 5. If I do 3 minus 5, this is minus 2. Now minus 2 is not a natural number. So that means natural numbers are not closed under subtraction.